Okay, hi everyone. I'm Mathilda. I'm an engineer at Deliveroo, and today I'm going to talk about concurrency and my journey from Ruby to Go. So a few weeks ago, my team were given a task to build a new service. The service had to be reliable, fast, so have a low latency, be able to handle a high number of requests, and be cost effective. So we went about designing our service, and during the design, we thought, well, which language should we choose? So everyone on the team knew Ruby, we were all familiar with it, but Ruby is not built for concurrency. And as I'm sure you all know, probably better than me, but Go has concurrency abstracted into the language. So I was really fascinated by this. You know, what does it mean? Like, how is Go different from Ruby? So I started doing some research. So just as a recap, what is concurrency and what is concurrency versus parallelism? So concurrency is the composition of independently executing processes that may use parallelism to do a better job. Whereas parallelism, which I can't say very well, is a runtime property where two or more tasks are being executed simultaneously. So I like to think of the kitchen analogy where, you know, if tonight you go home and you cook yourself dinner, you could be, you know, boiling hot water, you could be then going to cut up some vegetables and then going to the cupboard to go and, I don't know, pick up a pan. So you're doing lots of tasks, but you're not doing them all at the same time. Whereas if you and a friend decide to cook dinner together, you know, you could be stirring some vegetables and your friend could be chopping some carrots. So those two tasks are happening in parallel at the same time. So also a quick recap on process, threads, and cores. So a process is an instance of a computer program, and it has at least one thread of execution. And a thread is an entity within a process that can be scheduled by the CPU. And threads are more lightweight than processes, and they share the virtual address space and memory of a process. And a CPU core is capable of executing a single thread at a time. So remember, a computer can only do one thing at once, so a core can only execute one thing at a time. So now I'm going to look at the concurrency problem in Ruby. So imagine we know we want to build this service. We know that it's going to want to be able to handle a high number of requests. So say we've got, you know, lots of clients, and we've got a single process with 4 execution threads, and they're going to do some work and connect to the database and return the response back to the clients. So say the service normally has around 1,500 requests per minute. We know that's 25 requests per second, and we can see we've got 4 threads here that can accept HTTP requests. So that's around 6.25 requests per thread. And you can see if we say the normal response time is around a millisecond, then actually each thread could do 10 requests per second. So they've got a bit of headroom. So now, here. So then, you know, this is a Ruby application. What happens when 4% of the requests start taking 20 seconds? Say because of a slow database query or because of a network blip. And we know that now, you know, we host a lot of our software in the cloud, and network blips are frequent, so we need to be robust against them. So what's going to happen? So 4% of requests means, and we know that we have 25 requests per second, so that's one bad request a second. So here, after the first second, this thread is now busy. And it's going to be busy for the next 20 seconds. So if this application was just in Ruby, then the CPU scheduler would say, okay, this thread is now idle, and it would move the execution to the next thread. But then a second later, the next thread is going to receive a slow request, and this is also going to be blocked. And the same thing's going to happen the third second and the fourth second. So this is a Ruby application. I'm not even going to talk about Ruby on Rails, because Ruby on Rails is a request in and then a request out. So it wouldn't let the CPU scheduler switch between the threads. So you can see, if you have a network blip, or if you have a slow database query, how quickly these like HTTP acceptors or threads can become blocked and your service can become unavailable. So Ruby does not handle concurrency well. So this is where, Go comes to the rescue. And Go comes to the rescue because of Go routines. So for anyone who's new to Go, a Go routine is a function which is executing concurrently with other functions in the same address space. So, and also, this is really key because Go routines are typically very lightweight. So they're 2 kilobytes. Whereas a thread is normally between 1 and 2 megabytes. If I just go back to the last slide, a lot of you might have been like, well, if your threads are blocked, well, why can't you just auto-scale and add more instances? And the reason you can't do that is because if the threads are blocked waiting for a database query or a service to respond, the CPU utilization is still very low. So the autoscaler won't kick in because the CPU utilization won't increase. So then you're manually scaling up instances, and you just don't want to be doing that. You want a reliable service. So, threads are actually pretty heavyweight compared to these really light Go routines. So if we now look at, a similar setup, and how Go would handle slow database requests or slow queries to networks. So here again, I've got my clients, and they make a request to the service. So here, just for simplicity, I could have had multiple threads, but let's just stick for one thread, because Go's very good at this. And for every HTTP request, a Go routine is created. And a Go routine is almost like a virtual thread. So this Go routine is created, and then the Go runtime scheduler is going to schedule the Go routine onto the native OS thread to execute the function to do some work. And then if in the middle of that function there's a call to a database or there's a call to an external service, the runtime scheduler will see that Go routine is idle, so it will schedule it off this thread, and it will schedule another Go routine that wants to do some work onto this thread. So you can see that this thread is always busy. So if we think of the Ruby example before, where we had that really slow database query that was taking 20 seconds, this wouldn't be a problem here, because the slow database query would mean the Go routine would be taken off the thread, and another Go routine would be put on the thread. And also, Go routines are so lightweight, we can have tens and thousands of Go routines per process, whereas in a typical Ruby on Rails application, you have 16 to 20 threads, so they can just be saturated extremely quickly. So in conclusion, we wanted to design, a reliable, fast, and a highly available service. So with Ruby, we saw that threads are expensive and that they can get blocked very easily if there's, a slow database query or a slow request to an external service. And with Ruby on Rails, that's even worse. And with Go, so concurrency is built into the language with these amazing things, Go routines. And the Go routines are multiplexed on and off the native threads, and so services, are highly available. There's other things with Go that I haven't covered in this talk. The fact that it can execute multiple threads across multiple cores. But the main thing that I wanted to sort of explain was the difference between threads and Go routines, and how great Go routines are. So I'm just new to Go, but at Deliveroo, lots of services are being written in Go. There's lots of people helping me and teaching me, and I'm really enjoying it. So we are hiring. So if anyone's interested, send me an email or get in touch.
So I think this question, can you hear me? This question, I seem to ask every single talk now, but and someone asked it on the last talk. How far are you down the Go journey in that? Are you looking now at building new features in Go? Are you looking at building the whole architecture in Go and ditching Ruby entirely? Where are you on that process? Because there was a talk last time where they said, well, it's just impossible. We'd have to start from scratch if we were to ditch the Ruby inheritance.
Well, at Deliveroo, we have a service-based architecture, so it's kind of team by team. We were building a service on the hot path, so it had to be highly available. So Ruby on Rails just wasn't really a viable option for us. So it really depends what you're building, and the agreement that the team comes to. But, if you're building something that's going to be on a hot path, going to be hosted in the cloud, which is on the internet and not reliable, I think you've, got to think twice before you choose something like Ruby on Rails.
So you're going to build new features in Go in the future, do you think?
Well, it depends, what you're building.
Okay.
So, what choices would make you not want to build a service in Go now?
I can't think of anything because I'm working at a company where there's a lot of people writing Go, so I've got the support and the community around me. I guess if I was working by myself, maybe it's quite intimidating to, learn a whole new service and have to serve something in production that you don't have a huge amount of knowledge about, but nothing.